What kind of problem is this? Give me a term to match what I've just written. It is a binomial. So they may say factor the binomial using GCF. Again, math is all about terms. Factor the binomial. Two terms here. Binomial. Using GCF, meaning find the greatest common factor that you can pull out of the binomial. Okay? So instead of breaking this into two single monomials and putting an and sign in there saying find the GCF, we have a binomial. So what you want to do is look at each one of these terms and say, what's the GCF for those? And what am I left over with? Okay, so what is the GCF that I can pull out of 2x squared and 8x, and what am I left over with? Alright, so I chose an easy one here. Look at the number, 2 and 8. What's the GCF of 2 and 8? 2. Everybody agree with that? Good to go. X squared and x, what's the greatest amount of x's I can pull out? And this is a single x. That's my GCF. Now, I want to write the leftovers. What's left over when I pull that 2x out? If I take a 2 and divide it by 2, I'm left with a 1. Okay? If I take an x squared and divide by an x, how many x's are left? 1. Just 1x. Okay? Plus, if I take the 8 and I divide by the GCF of 2, how many is left? 4, because they're 4 times evenly. If I take an x and divide by an x, they go away, right? It's a 1. So guess what? We have factored this out. How do I know we factored? Because this is a product. This is a product here. And a product means that I have broken it down into two factors. Okay? There's two factors here. The first factor is the GCF, which is 2x. The second factor is a binomial. The second factor is x plus 4. Okay. Now, we just went backwards. 2 weeks ago, I would have given you this problem and said, hey, multiply this out. And what property would you have used? We would have distributed, right? We would have took the 2x and gave it to the x and the 2x and gave it to the 4. Guess what? That's a way to check yourself here. So if you want to check yourself to see if you got it correct, you take the problem and you distribute. 2x times x. What is that? 2x squared. I'm not making it up. It works. 2x squared. We're looking good so far. Then we take the 2x and multiply it times the 4. What do you get now? 8x, which is exactly where we started. So we know we got it right. And you knew I was going to draw a smiley face there. Okay? I'm all about checking myself. Algebra, it sets itself up. That's why it's so neat, is that once you figure out the process and you get an answer, you can actually check yourself to see if you got the answer correct. Okay? So what we are doing by factoring out the GCF is actually reverse distributive property. We're taking the distributive property and undoing it. Instead of giving out papers, what did I do? First thing, I came around this morning and took up everybody's quizzes, right? That was reverse distributive property. I distributed the quizzes yesterday, and I said, guess what? Everybody has a quiz. I'm going to take it up. Give me quizzes. Okay? Makes sense, right? All right, let's give you one for you to try, and I'll walk around to help people individually on this one. So what we want to do is we want to factor by the GCF, pull out the GCF, and make it a product. Pull out the GCF, see what's left over. These are the leftovers here. It's like division, because remember, factoring is product. So if you're going to pull something out, pull out a product, you're going to actually divide. 2x squared divided by 2x is x. 8x divided by 2x is 4. Okay? Everybody got that one written down? So everybody right now, I want you to factor this one by GCF, and I want you to check it. I got to make it up. All right, let's go 10x to the 4th minus 5x squared. Ladies and gentlemen, I don't think we had any issue with getting this. I don't think we had any issue getting 5x squared as the GCF. Okay? I'm glad. That's good. Understanding GCF is half the battle for this section. This is the GCF. It is the greatest common factor. But look, we got leftovers. Leftovers means what's left after I divide out the GCF. Okay. Now, here's a good way to think about this. Start with a binomial, you're going to have 2 leftover parts. If you have a trinomial, you'll have 3 leftover parts. If you have a polynomial with 57 terms, you'll have 57 leftover parts. Even though the part may be 1, it's still a part, right? Because something times this guy had to give you that term. Okay? So here's how you think. You say 10x to the 4th divided by 5x squared. Well, don't think about that holistically. Break it down into parts. 10 divided by 5 is what? 2. X to the 4th divided by x squared. X squared. Going back to some of your pre-algebra stuff, if you take x to the 4th and divide by x squared, you're actually going to subtract the exponents. 4 minus 2 is 2 left over. Okay? Now, we have a negative and we have a positive. Negative divided by positive is going to leave me with a negative. Okay? 5 divided by 5, that's 1. X squared divided by x squared, still 1. So guess what? We get the second factor to be 2x squared minus 1. We have broken this down into a product of 2 things, a monomial and a binomial. We have factored out the GCF. We have pulled out a 5x squared out of each term. Okay? To check it, we take what we have found and we do the distributive property. We say 5x squared times 2x squared minus 5x squared times 1. 5 times 2 is 10, x to the 4th minus 5x squared, which is what the original problem states, which is right, which makes me happy. Yes, yes? Good to go. Now I'm going to stick with the binomial this time, except for this time I'm going to make it a harder binomial. The process is still going to be exactly the same. Factor out the GCF, what do you have left over? Okay? Alright, so let's go with 80. A to the 4th, B to the 6th, C to the 8th, D to the 2nd. Okay? Plus 26, A to the 6th, C to the 5th, D to the 2nd. Okay? Now, so that we can keep going, keep rolling. Okay? GCF. 80 and 26 is 2. Okay? Hopefully you can figure that out. If you need help with that, I need to help you because I think we're beyond that point now. Do they have A's in common? Yes, they have 4. A to the 4th. Do they have B's in common? No, they do not. The second term does not have B's. Do they have C's? Yes, they do. C to the 5th. Do they have D's in common? Yes, they do. 2 apiece. That's the GCF. Okay? That's not the answer, though. We want to factor it completely by using the GCF method. So we've got to have some leftovers. There's 2 leftovers. How do I know there's 2 leftovers? Because we started with a binomial. There's going to be 2 leftover pieces. What's left over? Okay? You take each individual piece and you ask yourself, this divided by this gives me the leftover piece. 80 divided by 2 is 40. A to the 4th divided by A to the 4th is 1. There's no A's left over. It's just 1. They divide out. Okay? So I don't have to write a 1. 40 times 1 is still 40. Correct? B to the 6th divided by no B's. Well, actually, it's divided by 1. So there will be a B to the 6th here. We have to account for the B to the 6th because it's leftovers. It wasn't pulled out, so it's still there. Okay? C to the 8th divided by C to the 5th. If you're dividing things with exponents, you subtract the exponents. 8 minus 5 leaves me with a C to the 3rd. Last piece is D squared divided by D squared. D divided by D is going to be, well, actually we'll reduce to 1, right? So 1 times this is still going to be what we have up here. So guess what? That's what's left over for the first term.
How do you get C to the third?
How did I get C to the third? Yes. C to the 8th divided by C to the 5th. You subtract the exponents, 8 minus 5, you get C to the third. Okay? Second piece is the same process. 26 divided by 2 is going to give me 13. A to the 6th divided by A to the 4th. I'm going to subtract the exponents. 6 minus 4, I'm going to get A squared. C to the 5th divided by C to the 5th. They go away. It's going to equal out 1. I don't have to put the 1 in there because 1 times anything is just what I have written. Okay. D squared divided by D squared is going to be the same thing. They're going to divide out and equal 1. So guess what? That's what's left over. This is the second part. That is the second factor. This is the answer. The answer is 2a to the 4th, c to the 5th, d squared, times 40b to the 6th, c to the 3rd, plus 13a squared. You don't believe me? How do you check it?
Multiply it out.
Multiply it out, distribute it out. So let's distribute it out here. We're going to distribute. I'll change colors. Take this guy, multiply there and there. Alright, so we're checking here. Okay? We're checking 2a to the 4th, c to the 5th, d squared times this. If they have the same variables, we're multiplying, we add the exponent. 2 times 40 is 80. We're looking good. A to the 4th times no a, so it's just going to be a to the 4th. C to the 5th times c to the 3rd will be c to the 8th. But there's a b to the 6th. So if we're going to put it in the order, we go b to the 6th, and then c to the 8th, and then d squared. That's the same term as we have right here. So that's good. And we say plus. I'll flip over here. 2 times 13 is 26. And then we have a to the 4th times a squared, which is a to the 6th. We don't have any b's. We do have a c, c to the 5th. And then we have a d squared. And that matches the second term here. So I know we got it right.